Picture this: a world buried under sheets of ice, so massive they could swallow entire mountain ranges. Rivers of frozen water, miles thick, grinding entire continents into new shapes over thousands of years. This wasn't some distant sci-fi fantasy. It was Earth not so long ago, and though the ice has retreated, its fingerprints are everywhere, hidden in plain sight. The valleys we hike, the lakes we swim in, even the very soil beneath our feet, all bear the scars of a planet shaped by ice. But what if I told you these frozen giants left behind more than just physical marks? They encoded secrets about our past, our climate, and even our future. Think about the last time you stood at the edge of a breathtaking canyon or marveled at the smooth curves of a mountain range. What you're seeing isn't just geology, it's a frozen whisper from a time when ice ruled the world. The Ice Ages weren't just a phase, they were master sculptors, chiseling the planet into the landscapes we know today. And they didn't just shape the land, they rerouted rivers, trapped ancient air in bubbles of ice, and even influenced where human civilizations could take root. But here's the wildest part: these icy eras didn't just vanish without a trace. They left behind a treasure trove of clues, like nature's own time capsule, waiting for us to decode. So how do we raid this frozen ledger? That's the journey we're about to take. From the eerie, polished grooves in bedrock that tell the story of glaciers long gone, to the bizarre, erratic boulders dropped like forgotten toys by melting ice sheets, every detail is a piece of the puzzle. And it's not just about the past. The legacy of the Ice Ages is still shaping our world today, influencing everything from weather patterns to where we find fresh water. So buckle up, we're diving deep into Earth's frozen archives, unraveling mysteries that have been waiting beneath our feet for millennia. By the time we're done, you'll never look at a mountain or a lake the same way again. The Ice Ages may be over, but their story is far from finished. Let's uncover it together. To understand how Earth transforms into a frozen world, we need to step back, way back, and look at our planet from space. The trigger for Ice Ages isn't some sudden catastrophe or supernatural force. It's written in the slow, rhythmic dance of Earth's movement through the cosmos. Meet the Milankovic Cycles, a set of subtle orbital shifts named after the scientist who unraveled them. These cycles are like Earth's heartbeat, governing when ice blankets the continents and when it retreats. First, there's Earth's wobble, a slight variation in the planet's tilt that happens over 41,000 years. Imagine spinning a top. As it slows, it starts to lean. Earth does the same, tilting just a degree or two more or less on its axis. This tiny shift changes how sunlight hits the poles, turning them into ice-making factories or thawing them out. Then there's the shape of Earth's orbit around the Sun, which stretches and shrinks over 100,000 years. When the orbit is more oval, we swing farther from the Sun during winter, turning mild chills into deep freezes. But here's where it gets even more fascinating. These orbital shifts alone aren't enough to plunge the planet into an ice age. They're the spark, but the fire spreads thanks to feedback loops. As ice sheets grow, they reflect more sunlight back into space, cooling the planet further. Meanwhile, ocean currents, Earth's global conveyor belt of heat, can stall or shift, trapping cold air in key regions. And then there's the invisible player, greenhouse gases. When carbon dioxide levels drop, less heat gets trapped in the atmosphere, amplifying the cooling effect. What's truly mind-bending is how delicate this balance is. A drop in average global temperatures by just a few degrees can lock continents in ice for millennia. But then, like clockwork, the cycles reverse. The planet tilts back, the orbit rounds out, and suddenly, the ice sheets begin their slow retreat. It's a reminder that Earth's climate isn't static. It's a dynamic system, always oscillating between extremes. And buried in these cycles is a warning. If small changes can trigger an ice age, what happens when human activity disrupts the balance even further? The answer might just be written in the ice. Glaciers are Earth's slow but unstoppable architects, working with unimaginable force over millennia to redesign entire continents. Picture a river of ice, sometimes over 2 miles thick, inching forward with the weight of 100 skyscrapers pressing down on every square inch of bedrock beneath it. This isn't erosion, it's geological warfare. As glaciers advanced during the ice ages, they didn't just scrape the surface, they shattered mountains, pulverizing solid rock into fine powder like a giant sanding belt dragging across the planet. The proof is everywhere. Those sweeping, U-shaped valleys in places like Yosemite, that's the signature of a glacier's passage, a stark contrast to the V-shaped valleys cut by rivers. Glaciers don't meander, they plow, leaving behind broad, flat floors and steep, smoothed walls, as if the land had been hollowed out by a cosmic chisel. Then there are the fjords, those dramatic, water-filled canyons lining coasts from Norway to New Zealand. These aren't just flooded valleys, they're glacial masterpieces. As ice sheets crept toward the sea, they carved trenches so deep that when the glaciers finally melted, ocean water rushed in, creating those iconic steep-sided inlets. Some fjords plunge over 1,000 feet below sea level, yet their walls still bear the telltale scratches of ancient ice dragging boulders the size of houses across bare rock. And speaking of boulders, let's talk about glacial erratics, those lone, out-of-place giants perched in fields or on hillsides with no logical explanation. These are the ice sheet's lost luggage, rocks plucked from one continent and dropped hundreds of miles away as the glacier melted, stranded like geological orphans. But perhaps the most jaw-dropping glacial handiwork lies hidden beneath our feet. The Great Lakes, they're essentially giant potholes. As the Laurentide ice sheet, a monster covering much of North America, retreated, its meltwater filled the deep scars it had gouged into the bedrock, creating the largest freshwater system on Earth. Even more surprising, you don't need to visit iconic landscapes to see Ice Age evidence. Those gentle, rolling hills across the Midwest, glacial moraines, piles of rubble pushed forward by advancing ice like a bulldozer's dirty snowbank. The fertile soils of the American prairie, wind-blown glacial dust, so fine it was carried for miles before settling into the breadbasket of a continent. The eerie part, some of these changes happened almost overnight by geological standards. During catastrophic glacial floods, meltwater could carve entire canyons in days. Washington's channeled scablands, with their bizarre, rippled terrain, were sculpted by floods so powerful they'd make Niagara Falls look like a leaky faucet. This is the Ice Age's forgotten superpower, its ability to reshape the world not just through slow grinding, but in sudden, violent bursts. And as we piece together these clues, the polished bedrock, the misplaced boulders, the phantom lakes, we're not just reading Earth's history. We're seeing a preview of what future ice ages might do, because the glaciers will return. The only question is when. Now imagine stumbling upon a boulder the size of a small house, sitting alone in the middle of an open field, miles away from any mountain range where it might have come from. These are glacial erratics, nature's most baffling paperweights, scattered across landscapes from the American Midwest to the plains of Northern Europe. They shouldn't be there, and yet there they sit, silent witnesses to the unimaginable power of ice. the story of these rogue rocks begins with glaciers on the move. As ice sheets advanced during the Ice Ages, they didn't just slide over the land, they bulldozed it, ripping entire cliffs apart. Rocks of all sizes, from pebbles to monoliths, got trapped in the glacier's grip, frozen into its belly like cargo in a colossal, slow-moving freighter. Some traveled just a few miles, others rode hundreds, even thousands of miles, carried across continents at a pace of inches per year. Then, when the climate warmed and the ice melted, these hitchhikers were unceremoniously dumped, left stranded in alien landscapes with no explanation. Take Plymouth Rock, not the famous colonial landmark, but its lesser-known cousin in Massachusetts. This 600-ton granite boulder sits nearly 200 miles from its nearest geological match, a mystery that stumped early settlers. Or the Madison Boulder in New Hampshire, a 5,000-ton monster that looks like it was dropped from the sky. Even more mind-bending are the erratic trains, lines of boulders stretching for miles, tracing the exact path of a glacier's retreat like breadcrumbs left by a melting giant. But these stones aren't just geological oddities, they're time capsules. By studying their mineral composition, scientists can trace them back to their original bedrock, mapping ancient ice flow like detectives following a trail. Some erratics even carry scars from their journey, with deep grooves where they were dragged across other rocks like nails on a chalkboard. And then there are the legends they've inspired. For centuries, people concocted wild theories to explain them. Giants tossing boulders in fits of rage, biblical floods washing them inland, even extraterrestrial visitors leaving markers behind. The real magic, though, lies in what these wandering rocks reveal about Earth's climate past. Their placements contradict modern wind and water patterns, proving that ice, not rivers, moved them. Some erratics sit perched on fragile soil that would have collapsed if water had carried them, a clear sign they were gently lowered by melting ice. Others form boulder barricades at the edges of ancient glacial paths, marking where the ice sheet finally gave up and retreated. Yet mysteries remain. Why are some erratics made of rock types that no longer exist nearby? Did glaciers swallow entire mountains and redistribute their pieces? And what about the erratics found high atop hills, defying logic? These questions fuel scientific debates even today. But one thing's certain, every erratic is a message in a bottle from the Ice Ages, waiting to be decoded. The next time you see a lone boulder in a field, remember, it's not just a rock, it's a traveler, a survivor, and a map to a frozen world we're still learning to understand. Beneath the bustling cities and sprawling farmland of today lies a ghost network rivers that once roared with meltwater, now silent and buried under layers of sediment. These are the lost waterways of the Ice Ages, twisted and rerouted by glaciers like veins crushed under a frozen boot. When ice sheets advanced, they didn't just cover the land, they rewrote its plumbing, damming ancient channels, carving new ones, and leaving behind a hydrological maze that still baffles scientists. Take the Mississippi River, for example. Before the Ice Ages, it didn't flow south to the Gulf of Mexico at all. It emptied into the Arctic, following a path now buried under glacial debris. Then came the Laurentide ice sheet, bulldozing its way across North America and blocking the river's original course like a cork in a bottle. Trapped, the water had to find a new escape route, and that's how the Mississippi we know today was born. But its ancient bed is still out there, preserved beneath layers of silt like a fossilized artery. Even stranger are the underfit rivers, those quiet, meandering streams that seem far too small for the massive valleys they occupy. These are the leftovers of glacial floods so powerful they could have drowned entire states. The channeled scablands of Washington are the most dramatic example. where outburst floods from melting ice tore through the landscape like a fire hose, leaving behind canyons and dry waterfalls. Today, the Little Spokane River trickles through these scars, a timid remnant of the catastrophe that carved them. But how do we find these lost rivers? Modern technology is turning the ground transparent. LiDAR laser mapping that strips away vegetation reveals the faint contours of buried valleys hidden beneath forests and fields. In Europe, archaeologists using this technique discovered an entire prehistoric river system under the North Sea, where mammoths once drank from its banks before rising waters drowned the land. Meanwhile, ground-penetrating radar uncovers submerged channels under cities, showing where ancient waterways still influence groundwater flow and even modern flooding patterns. The most haunting evidence comes from misfit lakes, bodies of water with no obvious source, sitting in depressions scraped out by glaciers. Minnesota's 10,000 lakes are really just the puddles left behind by retreating ice, filling the holes where blocks of glacier once melted in place. And then there's the Great Basin in Nevada, where rivers still flow toward long-vanished lakes, their waters disappearing into the desert like echoes of a wetter world. What's startling is how alive these buried systems remain. Ancient aquifers filled during the ice ages still supply water to millions today. The Ogallala Aquifer in the U.S. Midwest, a vast underground reservoir, holds meltwater that fell as snow 20,000 years ago. And when engineers accidentally tap into lost rivers during construction projects, the water that gushes out hasn't seen sunlight since the last ice age. These phantom waterways are more than curiosities, they're warnings. As glaciers retreat today, they're once again reshaping river systems, threatening communities built on old floodplains. The difference this time, we're the ones melting the ice. The past shows us how suddenly water can change course, rewriting maps in a geological instant. The next time you cross a bridge or dip your toes in a stream, remember, you're standing on the ever-shifting blueprint of a planet still sculpted by ice. Deep in the Arctic, beneath layers of soil that have remained frozen for tens of thousands of years, lies one of Earth's most eerie archives, permafrost. This isn't just frozen ground, it's a time capsule locking away secrets from a world that vanished long before human civilization took root. Imagine soil so cold that a single summer's warmth can't penetrate more than a few inches down, preserving everything trapped inside in a state of suspended animation. Woolly mammoths with flesh still intact, ancient grasses that last sprouted when Neanderthals walked the earth, even the footprints of long-extinct creatures, all perfectly preserved like snapshots from a frozen past. But permafrost isn't just a museum. It's a vault holding something far more volatile, carbon. Over millennia, dead plants and animals that would have decomposed in warmer climates were instead flash frozen, locking away their organic matter in icy storage. Scientists estimate permafrost holds nearly twice as much carbon as the entire atmosphere today. And here's the catch: as temperatures rise and the Arctic warms at alarming rates, this frozen vault is cracking open. When permafrost thaws, microbes wake up from their slumber and start feasting on that ancient organic material, releasing carbon dioxide and methane greenhouse gases that accelerate global warming in a vicious feedback loop. The numbers are staggering. Some regions of Siberia are already belching out methane at rates 20 times higher than normal, with craters appearing where the ground has literally collapsed from thawing ice beneath. In Alaska, roads buckle and buildings tilt as the once solid ground turns to sludge. But the real wild card isn't just the carbon, it's what else might be waking up with it. In 2012, scientists revived a 30,000-year-old virus from Siberian permafrost, a pathogen that had been dormant since the Stone Age. While this particular virus only infects amoebas, it raises a chilling question. What else is buried out there? This isn't science fiction. In 2016, a heat wave in Siberia thawed permafrost and unearthed a reindeer carcass infected with anthrax, a disease that hadn't been seen in the region for 75 years. The outbreak hospitalized dozens and killed a child, a stark reminder that permafrost doesn't just preserve, it can also resurrect. Researchers are now racing to catalog potential threats, from ancient bacteria to viruses we've never encountered, all while grappling with an unsettling reality. We don't even know what we don't know. Yet permafrost also holds clues to our past. In Canada's Yukon, gold miners routinely stumble upon Ice Age relics, lion cubs with fur still soft, wolves with teeth intact, even a 40,000-year-old baby horse so well preserved its hooves look ready to gallop. These finds rewrite textbooks, offering unprecedented glimpses into extinct ecosystems, but every thawing chunk of permafrost is a race against time. Once exposed to air and warmth, these organic time capsules decay rapidly, vanishing before scientists can study them. The irony is profound. The very ice that once shaped our planet is now, as it melts, reshaping our future. Permafrost isn't just a relic of the ice ages, it's a living barometer of the changes we're unleashing. And as it thaws, it's not just revealing secrets from the past. It's sending us a message written in melting ice and escaping gas about the world we're creating. The question is, are we listening? Imagine standing face to face with a creature twice the height of an elephant, its shaggy coat dusted with frost, tusks curving like ancient scimitars. This wasn't some mythical beast, it was the woolly mammoth, just one of the many giants that once ruled the frozen world. The Ice Ages weren't just a time of glaciers and bitter cold. They were the golden age of megafauna, when continents teemed with animals so massive they'd make today's wildlife seem miniature in comparison. Take the woolly rhino, a tank-like herbivore armored in thick fur and a single, brutal horn, or the short-faced bear, towering over polar bears at 12 feet tall, capable of outrunning a horse despite its size. Then there was the saber-toothed cat, with fangs longer than steak knives, perfectly evolved for piercing the thick hides of Ice Age prey. These weren't just bigger versions of modern animals, they were marvels of adaptation, built to survive in a world where blizzards could last for generations. The secrets to their survival were written in their bodies. Mammoths had tiny ears and tails to reduce heat loss, while layers of fat and dense underfur kept them warm in temperatures that would kill most mammals today. Even their blood was different. Scientists studying preserved specimens found hemoglobin specially adapted to release oxygen more efficiently in freezing conditions. But the most astonishing adaptations belonged to the predators. The saber-toothed cat's jaw wasn't built for chewing. It was a precision weapon, hinged to open wider than any living cat's, delivering a single, lethal bite to the neck of its prey. Yet for all their evolutionary brilliance, these giants vanished with shocking speed as the ice retreated. The debate over their extinction reads like a forensic mystery. Was it climate change as warming landscapes replaced grasslands with forests? Or was it the arrival of humans whose spears and hunting strategies targeted the slowest, largest prey? The truth may lie in a deadly combination. In places like Rangel Island, mammoths survived until just 4,000 years ago, long after mainland populations died out, suggesting that isolation from humans gave them a fighting chance. But here's where the story twists. Some megafauna left behind clues so fresh, it's eerie. In Siberia, mammoth carcasses emerge from thawing permafrost with stomach contents still intact, revealing their last meals of buttercups and wildflowers. Cave paintings in France capture the likeness of woolly rhinos with startling accuracy, drawn by artists who may have glimpsed them alive. And then there's the tantalizing possibility that a few species outlasted the ice ages by millennia. Legends of hairy giants in remote mountains might just be fading memories of real creatures. The loss of these titans reshaped entire ecosystems. Without mammoths to trample saplings, forests spread, altering the planet's carbon cycle. The absence of giant grazers changed fire patterns as unchecked grass growth fueled larger wildfires. Even the soil itself became poorer, missing the nutrients once spread by megafauna migrations. Today, scientists debate whether reintroducing similar species could restore these ancient rhythms, a concept called rewilding that blurs the line between past and future. What lingers most is the unanswered question, could it happen again? As the planet warms, today's largest animals, elephants, rhinos, big cats, face pressures eerily similar to those that doomed their Ice Age cousins. The mammoth's fate isn't just a chapter from the past, it's a mirror, reflecting the fragile balance between life and the changing world it inhabits. Their bones whisper a warning across the millennia, adapt or vanish. The ice may be gone, but the lesson remains frozen in time. While woolly mammoths and saber-toothed cats relied on brute strength and thick fur to survive the ice ages, our ancestors took a different approach, one that would change the course of history. Early humans didn't just endure the frozen world, they conquered it through sheer ingenuity. Picture a small band of hunters tracking reindeer across a windswept tundra, their bodies wrapped in tailored hides stitched with bone needles, their feet protected by shoes lined with dried grass for insulation. This wasn't just survival, it was innovation in the face of extinction. The first key to human resilience was mastery of fire. Unlike other animals, humans didn't just seek warmth, they created it. Evidence from caves across Europe shows how groups gathered around hearths not just for heat, but for transforming their world. Fire-hardened spear tips cooked frozen meat to make it digestible and even helped tan hides for better clothing. In South Africa's Pinnacle Point caves, archaeologists found evidence of humans systematically burning bedding to repel insects, a 60,000-year-old pest control system. Fire became so central to survival that some groups carried smoldering embers for miles when migrating, treating them as precious cargo. Then there was the clothing revolution. While Neanderthals draped themselves in simple hides, Homo sapiens took protection to another level. Excavations at Dizadzuana Cave in Georgia revealed fibers twisted into thread dating back 30,000 years, the oldest known textiles. These weren't just crude coverings, they were layered garments with hoods, mittens, and even laced footwear. Analysis of lice DNA suggests humans started wearing clothes regularly around 170,000 years ago, coinciding with the first major glacial push into Europe. But the real breakthrough came with eyed needles around 40,000 years ago, allowing for snug, windproof stitching that could trap body heat like modern thermal gear. Survival wasn't just about technology, it was about teamwork. Hunting massive Ice Age megafauna required coordination that would put modern military tactics to shame. At the La Brea tar pits in California, researchers studying wolf and human fossils made a startling discovery. While solitary wolves often died young from injuries sustained in hunts, early humans showed remarkably few broken bones. The likely reason: they hunted in organized groups, surrounding prey and attacking from multiple angles to minimize risk. This cooperation extended beyond the hunt. At Russia's Kostenki sites, evidence shows entire communities coming together to construct winter dwellings from mammoth bones, some structures using bones from over 60 animals, implying trade networks spanning hundreds of miles. Perhaps most astonishing was early humans' ability to turn scarcity into advantage. When glaciers locked up fresh water, our ancestors followed receding ice edges to harvest seasonal bounties, spring fish runs, summer berry patches, autumn migratory herds. In the Levant, they developed grinding stones to process wild grains during lean winters. At Spain's El Juyo cave, a 14,000-year-old shrine suggests they even cultivated spiritual beliefs to cope with environmental stress, carving eerie face-like patterns into stalagmites as if seeking protection from the cold. The ultimate testament to human adaptability lies in our genes. Modern indigenous populations in Siberia and the Arctic carry unique genetic adaptations, like enhanced blood circulation to prevent frostbite and metabolisms optimized for high-fat diets, proof of natural selection in action. Meanwhile, the disappearance of Neanderthals, who had thrived in cold climates for 300,000 years before humans arrived, underscores a profound truth. It wasn't brute strength that won the ice ages, but creativity, community, and the relentless drive to innovate. Every time we zip up a jacket or gather around a campfire, we're channeling the same spark that kept our ancestors alive when the world froze over. Their legacy isn't just in bones and tools, it's in our DNA, written in the very ways we still solve problems today. 500 years ago, Europe shivered through a climate nightmare that would reshape history, the Little Ice Age. This wasn't the slow march of glaciers we associate with prehistoric ice ages, but a sudden, vicious cold snap that turned summer frosts into deadly norms and froze rivers solid enough to host winter fairs on the Thames. From the 1400s to the 1800s, temperatures plummeted, crops failed, and societies scrambled to adapt. Yet this wasn't just a story of suffering. It was a laboratory for human resilience, with consequences that echo into our modern climate crisis. Picture the winter of 1683, when Londoners roasted oxen on the frozen Thames as ice thickened to nearly a foot deep. Dutch painters like Hendrik of Verkamp captured the eerie beauty of the era, their canvases filled with skaters gliding past snow-laden windmills and frost-rimed barges. But behind these picturesque scenes lurked desperation. In Switzerland, advancing glaciers swallowed entire villages, their creeping ice walls crushing homes like kindling. Finnish records tell of famines so severe that families resorted to baking bread mixed with tree bark. Even warfare shifted. The Swedish army marched across frozen straits to invade Denmark in 1658. A maneuver impossible in today's milder winters. Agriculture bore the brunt of the cold. Vineyards vanished from England, and Norse settlements in Greenland starved as sea ice cut off supply routes. The price of grain in France skyrocketed by 600%, sparking riots that foreshadowed the French Revolution, yet some thrived in the chaos. Dutch merchants grew rich shipping Baltic grain south, while Russian fur traders found booming markets for pelts as demand for warmth soared. The cold even birthed new technologies. Farmers in the Alps developed early greenhouses heated by rotting manure to save fragile seedlings. What caused this climatic tantrum? Scientists point to a perfect storm of factors: diminished solar activity during the Maunder minimum, a period of few sunspots, increased volcanic eruptions spewing sunlight blocking ash, and disruptions to ocean currents like the Gulf Stream. Sound familiar? These are the same wild cards modern climatologists watch today, except now, human activity amplifies their effects. The Little Ice Age proves how delicate Earth's thermostat truly is. A dip of just 1 degree Celsius triggered societal upheaval. Yet today, we're hurtling toward 3 degrees of warming within decades. The most haunting parallel lies in the unintended consequences. When Europeans imported frost-resistant potato varieties from the Andes to survive failing wheat crops, they couldn't have imagined this humble tuber would later trigger Ireland's Great Famine when blight struck. Similarly, today's climate solutions like biofuels or carbon capture carry hidden risks we might only recognize too late. The lesson: climate change isn't just about thermometers, it's about domino effects. Art tells the final, poignant chapter. Compare Pieter Bruegel the Elder's snowy 16th century landscapes with his son's sunlit scenes, painted just decades later as temperatures rebounded. The contrast is a silent testament to how quickly the world can transform. As we face our own climate crossroads, the Little Ice Age whispers a warning. Civilization dances on a knife's edge between stability and chaos. The difference this time: we're not just bystanders to the change, we're the architects. High in the Alps, where glaciers have clung to mountain slopes for thousands of years, something extraordinary is happening. As the ice retreats at unprecedented speeds, it's peeling back layers of time, exposing landscapes untouched by sunlight since the Stone Age. In 2013, hikers near the Swiss-Italian border stumbled upon a cluster of tree stumps, their wood still fresh-smelling despite being buried under ice for over 6,000 years. These weren't fossils, they were snapshots of an ancient world, preserved like botanical time capsules in nature's deep freeze. This phenomenon isn't confined to Europe. From the Andes to Alaska, shrinking glaciers are giving up their secrets at an alarming rate. In Norway's Jotunheim Mountains, melting ice revealed a Viking-era horseshoe, its iron still intact after 1,000 years of frozen slumber. Canadian researchers recently recovered a 4,000-year-old dart shaft from a Yukon glacier, its feathered fletching perfectly preserved, a hunting tool lost by some long-vanished culture. Each discovery is like finding a page torn from Earth's diary, offering clues about how past civilizations adapted to climate shifts. But these treasures come with troubling context. The same melt exposing these artifacts is accelerating faster than most models predicted. Greenland's ice sheet, which holds enough water to raise global sea levels by 20 feet, is now shedding mass 6 times faster than in the 1990s. The Rhone Glacier in Switzerland, once a sprawling river of ice that inspired Victorian tourists, has retreated over a mile since 1870, with half that loss occurring in just the last 30 years. Scientists monitoring these changes face a race against time, documenting fragile organic materials before they decay in the open air, while simultaneously piecing together what their presence reveals about historical climate patterns. The most haunting revelations come from the ice itself. By analyzing air bubbles trapped in ancient glacial layers, researchers can read Earth's atmospheric history like tree rings. A core drilled from Antarctica's ice contains perfectly preserved samples of air from 800,000 years ago, showing carbon dioxide levels never exceeding 300 parts per million until the Industrial Revolution. Today, we've blown past 420 parts per million, a concentration the planet hasn't experienced in millions of years. Yet there's grim irony in these discoveries. As glaciers vanish, so does their ability to regulate Earth's climate. Ice reflects sunlight back into space, a phenomenon called the albedo effect, but exposed bedrock absorbs heat, creating a feedback loop that accelerates warming. The water rushing from melting glaciers is already altering ocean currents, disrupting marine ecosystems, and even changing the planet's rotation as weight redistributes from poles to oceans. What emerges from the melting ice isn't just artifacts or data, it's a warning. The same forces that preserved these time capsules for millennia are now unraveling at human hands. Each relic pulled from the thawing ice carries 2 stories, one of the world that was, and another, more urgent tale about the world we're making. As scientists scramble to document this vanishing archive, one truth becomes undeniable: we're not just observers of climate change. We're the architects of the next great melt, Imagine walking from London to New York, not by boat, but on foot, across vast plains that now lie hundreds of feet beneath the Atlantic waves. This wasn't some mythical land bridge. During the last ice age, when glaciers locked up so much water that sea levels dropped by over 400 feet, continental shelves became dry land, connecting continents and creating superhighways for early humans and animals. The English Channel, just a river valley cutting through an expanse of grasslands where mammoths grazed. The Bering Strait, a 1,000-mile-wide prairie called Beringia, where hunter-gatherers crossed from Asia into the Americas. These vanished landscapes are more than geological curiosities. They're the missing pieces of human history, now submerged in what we call the ocean. The mechanics behind these disappearing acts are deceptively simple. When ice sheets grow, they siphon water from the oceans like a planetary sponge. At the peak of the last glaciation, so much water was trapped in ice that Florida doubled in size, Australia merged with New Guinea, and the Persian Gulf became a fertile river valley dotted with human settlements. Then, as temperatures rose, the sponge was wrung out again. Melting ice sent torrents of water back into the oceans, drowning these lost worlds at rates that would terrify us today. Studies of coral reefs in Barbados reveal that around 14,000 years ago, sea levels sometimes rose by over 2 inches per year, fast enough to visibly change coastlines within a single lifetime. Some of the most compelling evidence lies beneath the North Sea, where fishermen routinely net mammoth bones and Stone Age tools dredged up from Doggerland, a once thriving ecosystem the size of California. Sonar mapping has revealed its drowned hills, rivers, and even campfires where humans cooked their meals 20,000 years ago. In the Black Sea, archaeologists debate whether a catastrophic flood around 7,000 years ago, when rising Mediterranean waters burst through the Bosporus, inspired Noah's Ark legends. Meanwhile, off India's coast, divers explore the sunken city of Dwarka, its stone walls and artifacts suggesting a sophisticated harbor swallowed by the sea around 3,000 years ago. Yet these ancient floods aren't just history, they're previews. Today, as glaciers melt and thermal expansion pushes oceans higher, we're witnessing the same forces that drowned Doggerland and Beringia. The difference, this time, the water is rising onto coastlines crammed with megacities and infrastructure. Venice's floods and Miami's king tides are mild compared to what's possible. During the last interglacial period, when temperatures were slightly warmer than now, seas peaked 20 to 30 feet higher, enough to erase entire nations. The scary part, current models struggle to predict how quickly Antarctica's ice might collapse under similar conditions. Hidden in these underwater ghost landscapes is a paradoxical truth. Sea levels don't rise evenly like water in a bathtub. Gravity from massive ice sheets actually pulls ocean water toward them, creating localized dips in sea level near glaciers. When Greenland's ice melts, for example, sea levels near its coast will temporarily drop as the gravitational pull weakens, while places like the Pacific Islands face disproportionate surges. This bizarre phenomenon explains why some ancient shorelines show conflicting evidence. What looked like stability in one region could mask catastrophe in another. The ultimate irony, many areas now sinking underwater were shaped by the ice ages themselves. The weight of glaciers depressed continents like Scandinavia and Canada, which are still rebounding upward like a mattress after someone stands up, while regions farther south, like the U.S. East Coast, tilt slightly downward, amplifying sea level rise. Even the sand on our beaches is legacy of the ice ages, ground up by glaciers and rivers over millennia. As beaches erode, we're quite literally losing pieces of that frozen past. What emerges from these submerged secrets is a dual revelation. First, coastlines have always been transient, with human memory far too short to grasp their fluid nature. Second, the forces that shaped them are still at work, only now we've become unwitting collaborators in the process. The next time you stand on a shoreline, remember, you're not on the edge of land, but on the ever-shifting frontier between ice, water, and human ambition. The question isn't whether the map will change again, but whether we'll heed its warnings before it's too late. Picture a desert storm, but instead of sand, imagine trillions of microscopic rock particles swirling through the air, powder so fine it could float across entire continents. This was the birth of Loess, the unsung hero of ancient agriculture. During the ice ages, glaciers acted like giant rock grinders, pulverizing mountains into dust. When the ice melted, raging rivers carried this silt toward floodplains, where fierce winds picked it up and scattered it like nature's fertilizer across vast regions. The result, blankets of mineral-rich soil so deep you could dig 100 feet down and still find its distinctive yellow-brown hue. Some of history's most influential civilizations owe their existence to this glacial gift. China's Loess Plateau, with deposits over 1,000 feet thick, became the cradle of early agriculture, its fertile grounds nurturing millet and wheat crops that fed dynasties for millennia. The same winds that carved the Gobi Desert delivered this bounty, building soil so soft farmers could till it with wooden sticks, yet so stable they carved entire cave dwellings into its cliffs. Halfway across the world, the Mississippi River Valley's lowest bluffs created America's breadbasket, while in Europe, the Danube Basin's fertile plains supported Neolithic villages that transitioned from hunting to farming. What makes Loess so special? Its secret lies in the structure. Each particle is angular, creating air pockets that retain moisture while allowing roots to penetrate deeply. Unlike dense clay or porous sand, Loess holds nutrients like a sponge, releasing them slowly to plants. Modern tests reveal astonishing fertility. Some deposits contain 20 times more available potassium than surrounding soils. But there's a fragility to this abundance. When European settlers plowed the Great Plains Loess without understanding its ecology, the result was the Dust Bowl, a stark reminder that even the richest soils demand respect. The distribution of these deposits reads like a map of ancient prosperity. Egypt's Nile Delta flourished not just because of river floods, but because wind-blown Loess from drying glacial lakes enriched its fields. In Afghanistan, the Bamiyan Valley's towering Loess cliffs allowed the carving of the giant Buddha statues destroyed in 2001, their very existence proof of how this sediment stabilized into near rock hardness when compacted. Even today, vineyards from Argentina to Moldova thrive on Loess terraces, their grapes benefiting from the soil's perfect drainage and mineral complexity. Perhaps most fascinating is how Loess chronicles climate history. In New Zealand, alternating layers of Loess and volcanic ash create a striped record of ice age cycles, darker bands representing warmer periods when plants stabilized the soil, lighter layers marking cold snaps when dust storms rage. Chinese Loess contains magnetic minerals that align with Earth's shifting poles, allowing scientists to date deposits with precision. These silent archives prove that civilization's rise was never guaranteed. It was built, quite literally, on the dust of ancient glaciers. The legacy continues beneath our feet. Modern cities like St. Louis and Frankfurt sit atop Loess deposits that determine their architecture's stability. Farmers from Ukraine to Nebraska still reap harvests from Ice Age winds, and as climate change dries regions once stabilized by vegetation, new dust storms carry Loess particles into the atmosphere, some reaching as far as the Amazon, where they replenish nutrients in rainforest soils. This invisible connection between ice, wind, and human survival reminds us that the planet's systems are deeply intertwined. The next time you bite into a loaf of bread or sip a glass of wine, consider this. You may be tasting the final gift of glaciers that vanished 12,000 years ago. Buried beneath the vast ice sheets of Greenland and Antarctica lies Earth's most detailed climate ledger, a frozen archive stretching back nearly 1,000,000 years. To read it, scientists embark on polar expeditions armed with drills that plunge thousands of feet into the ice, extracting cylinders of frost as delicate as antique glass. These ice cores are more than frozen water, they're time machines, preserving snapshots of ancient atmospheres in microscopic air bubbles and dust particles trapped layer by layer, like pages in a planetary diary. Each annual layer tells a story. Snow that fell during Roman times contains traces of lead from their smelters, while ash from medieval volcanic eruptions marks years of global cooling. But the real magic lies in the chemistry. By analyzing oxygen isotopes in the ice, researchers can reconstruct temperature fluctuations with astonishing precision. Heavier oxygen-16 isotopes dominate during warm periods, while lighter oxygen-18 increases when glaciers grow, a natural thermometer locked in ice. The layers also capture sudden climate swings. One Greenland core reveals that 12,000 years ago, temperatures in the North Atlantic spiked 15 degrees in just a decade, a blink of an eye in geological terms. Then there are the air bubbles, tiny time capsules of ancient atmospheres. Sealed under crushing pressure, these bubbles allow scientists to measure past carbon dioxide and methane levels directly. The results are sobering. For 800,000 years, CO2 oscillated between 180 and 300 parts per million, rising and falling with ice age cycles. But since the Industrial Revolution, that number has skyrocketed to 420 parts per million, a concentration last seen when early humans were first mastering fire. Even more telling is the rate of change. What once took millennia now happens in decades. Dust particles add another layer to the narrative. During glacial periods, stronger winds carried mineral grains from dried-up lakebeds and deserts, leaving dusty bands in the ice. These particles reveal past wind patterns, while pollen grains mixed in tell us which plants thrived. In Antarctica, ice cores even contain traces of iron from meteorites and lead pollution from ancient Greek and Chinese silver smelting, proof that human industry left its mark long before the modern era. The deepest cores reach back to surprising extremes. One Antarctic sample contains ice from 800,000 years ago, when Earth's climate rhythm mysteriously shifted. Before then, ice ages came every 41,000 years, matching Earth's axial tilt cycle. Afterward, they spaced out to 100,000 years, a puzzle still unsolved. Some theorize shifting ocean currents or continental drift triggered the change, but the ice keeps its secrets. What makes these frozen records unparalleled is their continuity. Tree rings can be ambiguous, sediment layers get scrambled by earthquakes, but ice cores provide an unbroken, global timeline. When a volcano erupted in Indonesia in 1257, its sulfuric acid signature appeared simultaneously in both Arctic and Antarctic ice, a synchronization that helps align timelines across hemispheres. This precision allows scientists to correlate ice data with Mayan drought records or Egyptian famine chronicles, weaving a unified story of human resilience in the face of climate shifts. Yet these icy archives are vanishing. As temperatures rise, meltwater seeps into ancient layers, washing away chemical clues. Some of the oldest ice in the Alps has already disappeared, taking irreplaceable data with it. Scientists now race to drill endangered glaciers, storing cores in freezer vaults like the Ice Memory Project's Antarctic Sanctuary. a modern Noah's Ark for climate history. The lesson in the ice is clear. Earth's climate has never been static, but the speed of today's changes stands unmatched in the geological record. Holding an ice core is like gripping a crystal ball, one that shows not just where we've been, but where we might be headed. As meltwater drips from shrinking glaciers, we're reminded that the very ice preserving our past may soon become a casualty of our present. Imagine standing where a mountain should be, but instead finding only a vast, shallow bowl in the earth, a silent witness to a cataclysm from the heavens. Now picture that same scar buried under a mile of ice, erased from memory for millennia. This is the puzzle scientists face when hunting for ancient asteroid impacts in regions once covered by glaciers. The ice ages didn't just reshape landscapes, they may have acted as Earth's cosmic eraser, swallowing evidence of violent collisions that could rewrite our planet's history. Take the case of Greenland's Hiawatha crater. Hidden beneath the ice sheet until 2018, this 19-mile-wide depression wasn't spotted by satellites or radar. It was detected through subtle gravitational anomalies. When researchers finally drilled through the ice, they found shocked quartz and melted rock, undeniable fingerprints of an asteroid strike. But here's the twist. The crater's pristine condition suggests it's geologically young, possibly formed as recently as 12,000 years ago, right as the last ice age was ending. If true, it raises a haunting question. Could a cosmic impact have accelerated the glacier's retreat? The challenge of finding these hidden craters is like playing planetary detective with half the clues missing. Glaciers don't just cover impact sites, they actively destroy them. Advancing ice sheets act like conveyor belts of destruction, scraping away crater rims and scattering debris across continents. Meltwater floods the cavities, smoothing their edges. Even the telltale ejecta, the spray of molten rock flung outward during impact, gets bulldozed into unrecognizable heaps. This explains why regions like Scandinavia, scoured repeatedly by ice sheets, show far fewer craters than geologically stable areas like Australia, despite having similar exposure to asteroid threats. Yet sometimes the ice preserves rather than erases. In Canada's remote Northwest Territories, the half-mile-wide Whitecourt crater lay hidden under forest until a hunter noticed its peculiar circular shape in 2007. Investigation revealed it was carved into glacial sediments, meaning the asteroid struck when the area was already ice-covered. The frozen ground acted like a recording medium, capturing every detail of the explosion, right down to the distribution of thousands of meteorite fragments frozen in place like shrapnel in time. The most startling revelations come from beneath Antarctica's ice. Radar surveys have identified at least 24 circular anomalies that could be buried craters, including one beneath the Wilkes Land ice sheet that measures nearly 300 miles across. If confirmed as an impact site, it would dwarf the dinosaur-killing Chicxulub crater and might explain the mysterious extinction event 250 million years ago that wiped out 90% of Earth's species. But proving these hidden structures requires drilling through miles of ice in the planet's harshest environment, a task so daunting that some candidates may remain mysteries for decades. What emerges from this icy detective work is a paradigm shift. For years, scientists assumed Earth's crater record was incomplete due to erosion and tectonic activity. Now we must consider another culprit, glaciers as cosmic janitors, scrubbing away evidence of our planet's most violent encounters. Every hidden crater found, like Estonia's Colli, formed when a meteorite shattered into pieces over a frozen lake, offers new clues about how often Earth has been struck and how these events may have triggered or amplified ice ages themselves. The implications stretch beyond geology. if major impacts occurred during human prehistory, as some researchers argue based on nanodiamond deposits in ice cores, they could explain sudden collapses in ancient civilizations or bizarre climate anomalies recorded in tree rings. The ice giveth and the ice taketh away. While it may have shielded our ancestors from witnessing apocalyptic firestorms, it also buried the evidence we need to understand these game-changing events. As glaciers retreat at alarming rates, they're not just exposing lost landscapes, they're uncovering a celestial shooting gallery we never knew existed. The next great impact crater might be hiding in plain sight, waiting beneath the thinning ice for its story to be told. Beneath Antarctica's frozen surface, where sunlight hasn't penetrated for millions of years, lies a network of alien-world subglacial lakes trapped between bedrock and ice so thick it distorts time. Lake Vostok, the largest of these hidden realms, is roughly the size of Lake Ontario, buried under 2.5 miles of ice. For 15 million years, this liquid pocket has existed in complete darkness, under pressure so intense it would crush a submarine, in cold that would freeze ordinary water solid, except here, the ice sheet's weight lowers water's freezing point, creating a paradoxical oasis of liquid in a frozen desert. Drilling into these lakes is like cracking open a time capsule from another planet. When Russian scientists finally reached Lake Vostok's surface in 2012, they found water teeming with microbial life organisms that rewrite the rules of survival. These aren't your typical bacteria. They're extremophiles that feast on minerals scraped from bedrock or organic matter buried since Antarctica was a temperate forest. Some derive energy from hydrogen gas produced by water reacting with iron-rich rocks, a process called chemosynthesis that could mirror how life survives on icy moons like Europa. Others cling to microscopic air bubbles trapped in the ice above, harvesting ancient atmospheric gases like tiny time travelers dining on prehistoric air. The logistics of exploring these lakes border on science fiction. To avoid contaminating pristine ecosystems, engineers developed thermal drills that melt through ice with sterilized hot water, then recoil before breaking through to the lake, allowing water to rise and freeze in the borehole, creating a plug that maintains the lake's isolation. When researchers sampled this newly frozen water, they discovered genetic fragments from over 3,000 unique organisms, including bacteria with DNA repair mechanisms so advanced they can fix radiation damage without sunlight. These microbes don't just endure extreme conditions, they thrive in them, suggesting life might flourish in similarly hostile environments across the solar system. Lake Whillans, another subglacial wonder, revealed even stranger secrets. Here, a community of microbes survives by breathing iron compounds instead of oxygen, while others metabolize ammonium, a chemical signature typically associated with decay. But the real shock came when scientists detected signs of a microbial nitrogen cycle, a process thought to require sunlight. Somehow, these organisms have hacked Earth's biochemistry to recycle nutrients in perpetual darkness. Even more astonishing, some species appear to be hybrids of bacteria and archaea, two fundamentally different branches of life, blurring the lines of our evolutionary tree. What makes these discoveries revolutionary isn't just the existence of life, but its implications. Jupiter's moon Europa and Saturn's Enceladus harbor global oceans beneath icy shells, with hydrothermal vents potentially mirroring those feeding subglacial lakes. When the Cassini spacecraft detected organic molecules in Enceladus's geysers, it hinted at chemistry ripe for life. Antarctica's hidden lakes suggest that even without sunlight, organisms can exploit chemical imbalances between water and rock, a blueprint for survival that might span the cosmos. Yet the lakes guard their mysteries fiercely. When British researchers drilled into Lake Ellsworth, their equipment failed at the last moment. Lake Mercer, explored in 2018, contained unexpected oxygen levels, challenging assumptions about how gases dissolve under ice. Each setback reveals how much we still don't understand about these alien habitats in our own backyard. The ultimate lesson lies in resilience. If life can persist in Antarctica's sunless prisons, where pressures distort molecules and energy is scarcer than in any desert, then the universe might be far more habitable than we dreamed. Every scoop of icy water from these depths isn't just a scientific sample, it's a message in a bottle from Earth's most unyielding survivors, whispering that life finds a way, even when the world freezes over. Scattered across landscapes once buried under ice, thousands of smooth, egg-shaped hills stand like silent sentinels of a frozen past. These are Drumlins, nature's perfect teardrops of Earth, some stretching half a mile long yet so symmetrical they look almost sculpted by hand. From the fields of Ireland to the plains of Wisconsin, these enigmatic formations cluster in sprawling, drumlin fields, their long axes all pointing in the same direction like compass needles frozen in time. But despite their orderly appearance, drumlins hold a messy secret. Geologists still can't agree on how they formed, turning these unassuming hills into one of the Ice Age's greatest unsolved riddles. The classic theory paints a picture of glaciers as master artists, molding the land beneath them like clay. As ice sheets advanced, they supposedly scraped up loose sediment, sand, gravel, even boulders, and smeared it into streamlined shapes under millions of tons of pressure. The drumlins' tapered ends point in the direction the glacier was moving, their steep faces marking where the ice paused or thickened. This explanation seems elegant until you notice the inconsistencies. Some drumlins contain solid bedrock cores, defying the piles of debris model. Others appear in clusters where adjacent hills show completely different internal compositions, as if formed by different processes side by side. Then there's the flood theory, a dramatic alternative that rewrites the drumlin story as a catastrophe. Picture meltwater from retreating glaciers bursting through ice dams with the force of 1,000 Niagaras, scouring the land in turbulent, fast-moving currents. These torrents could have eroded some areas while depositing sediment in others, carving drumlins like river stones shaped by rapids. Evidence comes from drumlinoid features found near ancient flood channels in Washington Scablands, where similar-looking mounds formed in mere days during glacial outbursts. But critics point out that most drumlins lack the telltale layering seen in flood deposits. Their interiors often chaotic mixes of material more consistent with glacial grinding. The plot thickens with discoveries from under modern glaciers. In Antarctica, radar has revealed embryonic drumlins forming beneath active ice streams, some growing, others eroding, all shifting position like slow-motion dunes. This suggests drumlins might be dynamic features, evolving over centuries as ice moves and melts. Yet even these observations raise new questions. Why do some glaciers produce drumlins while others don't? And why do they often appear in sudden swarms rather than evenly distributed patterns? Perhaps the most tantalizing clue lies in their perfect geometry. The ratio of a drumlin's length to its width is consistently around 3:1, mirroring the aerodynamic efficiency of airplane wings or submarine hulls. This hints at some universal fluid dynamic principle at work, whether the fluid is ice, water, or some combination. Computer models now simulate drumlin formation using algorithms borrowed from aircraft design, treating the hills as nature's solution to minimizing resistance against flowing ice. The real magic of drumlins isn't just in their origins, it's in their legacy. These hills have shaped human history as profoundly as geology. In Ireland, drumlin fields dictated settlement patterns, their well-drained slopes becoming natural strongholds for castles and farms. Boston's Bunker Hill is actually a drumlin, its strategic height pivotal in the American Revolution. Even today, their rich soils make drumlin belts agricultural gold mines, while their rocky cores provide ideal road-building material. What makes these humble hills so captivating is their refusal to fit neatly into any single theory. They're reminders that Earth's most common landscapes often hold the deepest mysteries. Every drumlin field is a frozen snapshot of a glacier's last dance, a riddle written in dirt and ice, waiting for the right key to unlock it. As long as these teardrop hills dot our countryside, they'll keep challenging us to rethink how ice, water, and earth conspire to reshape the world. Deep in the caves of Europe, where winter's grip never loosened, our ancestors left behind something extraordinary, not just footprints or tools, but art. These aren't crude scratchings, they're masterpieces painted with ochre and charcoal, carved from mammoth ivory, and etched into stone with startling precision. The Ice Age wasn't just a fight for survival, it was humanity's first gallery, where early artists captured the beauty and terror of their frozen world. Take the caves of Lascaux in France, where walls explode with life 17,000 years after the paint dried. Aurochs charge across rock faces, their muscles taut with movement. Horses gallop in herds, their manes flowing as if caught in an ancient wind. But it's the predators that mesmerize the lions, bears, and woolly rhinos, rendered with such anatomical accuracy that modern zoologists can identify species from their profiles. These weren't doodles, they were careful observations, likely passed down through generations of artists who studied these animals in life and death. The shading, the perspective, even the use of rock contours to create depth, every technique hints at a sophistication we rarely attribute to cave people. Then there are the mysteries hidden in the symbols. Among the animals, strange geometric shapes repeat, dots, zigzags, handprints, and even what appear to be star maps. At El Castillo Cave in Spain, red discs painted over 40,000 years ago might represent celestial bodies or shamanic visions. The famed Venus figurines carved from stone or ivory with exaggerated curves could be fertility symbols, goddess worship, or even early medical models documenting pregnancy. What's undeniable is their intentionality. These creators weren't just decorating, they were encoding knowledge, beliefs, and perhaps warnings about their unpredictable world. The materials themselves tell a story of ingenuity. In the pitch-black recesses of caves like Chauvet, artists worked by the flickering light of animal fat lamps, mixing pigments with binders like egg whites or plant sap. They used blowpipes to spray paint around outstretched hands, creating the world's first stencils. Some even exploited cave acoustics, placing paintings in chambers where sound reverberated eerily, suggesting rituals or storytelling performances. And it wasn't just paint in Siberia. Archaeologists found a 30,000-year-old bracelet made from chlorite, its surface polished to a mirror shine and drilled with holes finer than a modern needle. But why create art in an age of scarcity? One theory points to survival. Hunter-gatherers might have believed capturing an animal's image gave power over its spirit. Another suggests these were teaching tools, helping young hunters memorize prey behaviors. Then there's the radical idea that art itself was an evolutionary advantage, strengthening social bonds and abstract thinking in a changing climate. Whatever the reason, the results transcend time. When you stand before a cave painting, you're not just seeing a mammoth, you're seeing through the eyes of someone who stared down the Ice Age and chose to create, not just endure. The most haunting works come from the end of the last glacial period. As temperatures rose and landscapes shifted, cave art changed. Fewer herd animals, more solitary creatures and human-animal hybrids. At Göbekli Tepe in Turkey, pillars carved with foxes and vultures suggest a culture grappling with extinction and transformation. These late Ice Age artists weren't just decorating, they were documenting a world in flux, preserving what they feared might vanish. Today, these creations challenge our assumptions about primitive societies. The Lion Man of Hohenstein Stadel, a 40,000-year-old ivory sculpture, combines human and feline features with a symmetry that would impress modern sculptors. The Altamira bison, painted with such vivid realism that 19th-century archaeologists accused its discoverers of forgery. These works prove creativity didn't evolve, it emerged fully formed, a spark of genius in the deepest freeze. What's left is a question as vast as the ice sheets themselves. Did art help humanity survive the Ice Age, or did the Ice Age force humanity to invent art? The caves don't answer, but their walls still whisper. Every stroke of pigment, every carved curve, is a message from minds not so different from our own people who looked at a world of snow and saw something worth remembering. Long after the glaciers melted, their vision remains, frozen not in ice but in time. Every coastline we know today is a lie, or at least a temporary arrangement. 20,000 years ago, when ice sheets reached their peak, so much water was locked away that sea levels plummeted by over 400 feet, exposing vast stretches of land now lost beneath the waves. These drowned landscapes weren't just empty plains, they were highways, homes, and hunting grounds for our ancestors. The Ice Ages didn't just shape mountains, they dictated where humans could go, when, and how. Take the land bridge connecting Asia and North America, what we now call Beringia. Today, the Bering Strait is a frigid channel 55 miles wide, but during the last glacial maximum, it was a 1,000-mile-wide grassland, teeming with mammoths, bison, and the humans who followed them. This wasn't some narrow crossing. It was a continent in its own right, with rivers, lakes, and even forests in sheltered valleys. Archaeologists have found evidence of campsites on now submerged islands like the Domed Group, where hunters butchered game and crafted tools while gazing across a landscape that's now entirely underwater. The bridge didn't just exist for a few generations, it persisted for thousands of years, long enough for entire cultures to adapt to its rhythms before rising seas swallowed it whole. But ice didn't just create paths, it also slammed doors shut. Europe during the last Ice Age was a fortress with glacial walls. The Alps and Scandinavian ice sheets merged into a nearly impenetrable barrier, forcing human populations into isolated refuges along the Mediterranean and the Atlantic coast. DNA studies reveal a genetic bottleneck during this period, proof that entire groups were cut off or wiped out by advancing ice. Those who survived did so by adapting in extraordinary ways, like the Gravettian hunters who followed migrating reindeer herds across frozen steppes, crafting parkas from animal hides and burning bone marrow as emergency fuel when wood ran scarce. Then there are the ghost settlements, places where humans thrived for millennia, only to vanish beneath rising tides. Off the coast of Australia, underwater archaeologists have found stone tools and hearths on the continental shelf, remnants of a coastal highway used by the first Aboriginal peoples 65,000 years ago. In the Persian Gulf, a once fertile valley called the Gulf Oasis may have supported tens of thousands before being inundated around 8,000 years ago, scattering its inhabitants and seeding Mesopotamian myths of a great flood. Even the North Sea hides a lost world Doggerland, a sprawling lowland where mammoths walked and Mesolithic fishers cast nets, now remembered only in the occasional trawler's net full of ancient bones. The cruel irony, many of these drowned lands were among the most hospitable places on Earth during the Ice Ages. While glaciers scoured continents, coastal shelves benefited from milder maritime climates and abundant marine resources. Shell middens in Florida and South Africa reveal that some of the earliest semi-permanent villages were built on now submerged shores, where predictable tides and rich estuaries allowed people to stay put longer than inland hunters could. When the ice melted, these prime locations became death traps, rising waters swallowing not just land, but entire ways of life. What emerges from these vanished worlds is a pattern of resilience and reinvention. Every time ice advanced or seas rose, humans didn't just retreat, they adapted. They took to boats when valleys flooded, switched from mammoth to seal hunting when grasslands drowned, and passed down oral maps of landscapes that no longer existed. The echoes of these adaptations linger today in Inuit legends of underwater villages, Aboriginal songs describing coastal features now miles offshore, even the persistent human preference for living near water, as if our DNA remembers when the shoreline was 100 miles farther out. The lesson written in ice and water is clear. Migration isn't just a human story, it's a planetary one. The routes our ancestors walked, the settlements they built, the cultures they forged, all were shaped by forces far beyond their control. As modern sea levels rise once more, we're not just facing an environmental crisis, we're reliving an ancient cycle, one that tests whether we've truly learned from the past or if we're doomed to repeat its retreats. Buried beneath layers of volcanic ash and glacial till, entire forests stand frozen in time, not petrified into stone, but preserved with bark still intact, leaves still clinging to branches, and stumps still rooted in soil from 30,000 winters ago. These fossilized woodlands are nature's time capsules, capturing the moment glaciers bulldozed through ecosystems with the precision of a paused film reel. At the base of Montana's Yellowstone National Park, the Amethyst Mountain Fossil Forest reveals a ghostly tableau. Dozens of ancient redwood trunks, some towering over 20 feet tall, their growth rings pressed together like pages in a book. These trees didn't slowly fossilize, they were flash-buried by volcanic eruptions, then entombed under ice, creating a cross-section of prehistoric life interrupted mid-breath. The real magic lies in the details. Split one of these fossilized logs, and you'll find cell structures so perfectly preserved under microscopes that scientists can identify the species' modern relatives. Some, like the Metasequoia dawn redwoods, were thought extinct until living specimens were discovered in China, proving these Ice Age forests held survivors from even older warm periods. But it's the growth rings that tell the most dramatic stories. Unlike modern trees with consistent annual bands, fossil forests show erratic patterns, years of stunted growth followed by sudden bursts, like a heartbeat faltering under stress. These are the fingerprints of climate chaos, volcanic winters blocking sunlight, followed by warmer interludes when glaciers briefly loosened their grip. Some forests reveal even stranger fates. On Ellesmere Island in the Canadian Arctic, now a polar desert, fossilized cypress stumps sprawl across the tundra, their roots still embedded in soil that once teemed with insects now extinct. Chemical analysis of the wood shows these trees didn't just die when cold came, they starved. As temperatures dropped, their ability to photosynthesize shut down, leaving behind rings that narrow to nothing over decades, a slow suffocation recorded in lignin and cellulose. Yet just a few layers deeper in the rock, older stumps tell a different story. Forests that thrived during brief warm spells, their wide rings and dense wood proving the Arctic wasn't always a frozen wasteland. The most haunting fossil forests aren't on land at all. Dive 60 feet beneath the waters of the North Sea, and you'll find the Doggerland Forest, its oak and hazel stumps still anchored to a seabed that was once dry land. When glaciers melted and seas rose, these trees didn't just drown, they were pickled by cold, oxygen-starved water, preserving even their pine cones and pollen. Fishermen trawling the area still haul up chunks of bog oak so fresh, looking they're mistaken for modern driftwood until radiocarbon dating reveals their true age, over 7,000 years. What makes these frozen forests invaluable is their testimony about resilience. In Alaska's Seward Peninsula, a fossil spruce stand shows trees that adapted to permafrost by growing shallow, sprawling roots, a survival tactic their modern descendants still use. Others, like the larch forests preserved in Siberia's Batagayka crater, contain layers of volcanic ash between growth bands, proving they weathered catastrophe after catastrophe before finally succumbing. These aren't just snapshots of extinction, they're instruction manuals for survival in a changing climate. As glaciers retreat today, new fossil forests are emerging from the ice, their thawing trunks releasing trapped carbon and rewriting our understanding of prehistoric ecosystems. Each one is a puzzle box waiting to be opened, its rings holding encrypted messages about how life endures when the world freezes over. The next time you walk through a modern forest, remember, beneath your feet could lie the bones of its ancestors, silently waiting to tell their stories. Deep beneath the rumble of earthquakes and volcanoes, Earth has another seismic language, one written in cracking ice and collapsing glaciers. These aren't your typical tremors, they're cryoseisms or ice quakes, sudden jolts that shake the ground without tectonic plates ever moving. Picture a glacier the size of Manhattan suddenly lurching forward, its sheer weight fracturing bedrock with enough force to register on seismographs thousands of miles away. In Greenland alone, scientists now detect over 10,000 of these frozen earthquakes every year, each one a whisper from ice sheets in distress. The mechanics of an ice quake read like nature's version of a structural failure. As meltwater seeps into crevices, it acts like hydraulic fluid, lubricating the glacier's base until pent-up tension releases in a violent snap. Some events last mere seconds, producing high-frequency waves geologists call glacial screams. Others unfold in slow motion, like the Helheim Glacier's 20-minute-long rupture in 2010, which sent a chunk of ice 4 times the size of Central Park tumbling into the sea. What makes these quakes so unnerving is their unpredictability. Unlike tectonic faults that follow centuries-long cycles, ice obeys no timetable. A glacier can remain silent for decades, then unleash a swarm of quakes in a single melt season. Scientists are turning these vibrations into a Rosetta Stone for glacial health. By planting seismometers on ice sheets, researchers can eavesdrop on events too remote or too subtle for satellites to catch. The signals reveal hidden dramas, rivers of meltwater surging through subglacial tunnels, ice shelves groaning as they flex with tides, even the eerie tremor harmonics that precede catastrophic calving events. In Antarctica, this seismic network caught something startling. A massive ice quake in 2016 that rippled across the Ross ice shelf for over an hour, its waves traveling hundreds of miles. Analysis showed the shelf had nearly fractured clean through, saved only by a thin buffer of resilient ice, but the real revelation lies in the patterns. Ice quakes are migrating inland on Greenland's glaciers, a sign that warming isn't just melting edges, it's destabilizing ice far from the coast. Some glaciers now exhibit doublet quakes, pairs of tremors minutes apart, suggesting meltwater is finding new pathways through deteriorating ice. The most troubling events are tsunami quakes, where collapsing ice triggers seismic waves that mimic underwater landslides, a phenomenon previously seen only in submarine geology. What's emerging is a chilling paradox. The same forces that paralyze landscapes with ice also make them shudder with seismic energy. As the planet warms, these frozen quakes are becoming more than curiosities, they're distress signals from a world in flux. Each creak and groan from the ice is a reminder that glaciers aren't static monuments, but living, moving, and sometimes screaming giants. And just like earthquakes, we're only beginning to understand their language, one violent tremor at a time. Imagine a river of ice, miles thick and heavy as a mountain range, grinding its way across the landscape like a slow-motion bulldozer. Now picture that same glacier as nature's most relentless gold panner, sifting through bedrock with unimaginable force, leaving behind the richest veins of precious metals the world has ever seen. This isn't just geology, it's the hidden reason behind some of history's most legendary gold rushes. From the Klondike to the Alps, glaciers didn't just shape valleys, they sculpted fortunes, turning entire regions into treasure chests of concentrated wealth. The process starts with the glacier's brutal efficiency. As ice sheets advance, they act like cosmic sandpaper, scraping away softer rock while tearing loose chunks of harder mineral-rich formations. Gold, platinum, and other heavy metals once scattered thinly through bedrock get caught in this frozen conveyor belt. But here's the twist: unlike water, which can carry gold particles downstream, glaciers transport them intact, crushing and mixing them into a glacial till of sediment. When the ice finally retreats, it leaves behind this chaotic mixture in ridges called moraines, essentially giant piles of unsorted rubble. Hidden within are dense pockets of ore, sometimes hundreds of times richer than the original bedrock. Nowhere is this more dramatic than in the Klondike. The famous Bonanza Creek, where prospectors struck gold in 1896, wasn't just a lucky find. It was the direct result of Ice Age glaciers redistributing ancient quartz veins. The gold hadn't traveled far from its source. The glacier had simply concentrated it like a cosmic sluice box, dropping heavy particles where melting ice lost its carrying power. Similar stories unfold worldwide. In New Zealand's South Island, glaciers ground gold-bearing rocks into flour-fine particles, then deposited them in riverbeds that later sparked the Otago Gold Rush. The Alps tell the same tale. Switzerland's iconic Rhone Glacier left behind moraines so mineral-rich that medieval miners followed them like treasure maps. But glaciers didn't just leave gold lying around. They created the perfect conditions for supercharged ore formation. As ice retreated, meltwater seeped into fractured bedrock, dissolving trace metals and redepositing them in concentrated seams. In Colorado's San Juan Mountains, these post-glacial hydrothermal systems created the famous epithermal veins that made towns like Telluride legendary. Even more fascinating are the placer deposits in former glacial lakes, where swirling meltwater sorted heavier metals into dense layers, like a natural centrifuge spinning gold to the bottom. The legacy lives on in modern economies. Canada's Abitibi gold belt, shaped by ancient ice sheets, still produces over 18 million ounces annually. Scandinavia's glacial valleys hide platinum reserves so vast they're fueling a new mining boom. And in Chile, the Andes glacial history helps geologists predict where the next copper bonanza might lie. But there's a darker side. Some of the most mineral-rich moraines now face destruction as melting glaciers expose these deposits to uncontrolled mining, threatening fragile ecosystems with mercury and cyanide runoff. What's truly mind-bending is how recently this all happened. The glaciers that sculpted these riches vanished just 12,000 years ago, a blink in geological time. Their meltwater still flows through the same valleys where 49ers panned for gold, connecting the Ice Age's mechanical might to the pickaxes and dreams of pioneers. Every glittering nugget found in a streambed isn't just a relic of Earth's fiery depths, it's a frozen fingerprint, proof that even the coldest epochs could set the stage for fortune. The next time you see a map of goldfields, look beyond the human stories. You're really reading the diary of a glacier's slow, relentless work. Beneath the modern world's hum of machinery and glow of city lights lies an ancient energy legacy, one forged not by human hands but by the crushing weight of ice ages. The coal powering factories, the oil fueling cars, even the natural gas heating homes, all owe their existence to a delicate dance between climate extremes and geological chance. It's a paradox. The same glaciers that buried continents under mile-thick ice also helped create the very fuels now melting their remnants. Rewind 300 million years to the Carboniferous period, Earth's greatest coal-forming epoch. Vast swamp forests stretched across tropical latitudes, their towering ferns and primitive trees sucking carbon dioxide from the atmosphere at unprecedented rates. When these plants died, they didn't decompose fully. Instead, they sank into oxygen-poor water, piling up as thick layers of peat. Then came the ice ages. As glaciers advanced and sea levels dropped, these peat bogs were buried under sediment washed from newly exposed continental shelves. The weight of ice sheets pressing on adjacent landmasses created the perfect pressure cooker environment, slowly baking the peat into coal over millions of years. The Appalachian Mountains coal seams some 30 feet thick, are essentially frozen sunlight from an age when dragonflies had 2-foot wingspans, preserved by ice age dynamics we're only now unraveling. Oil formation tells an even more intricate story. While most associate petroleum with deserts today, its origins often trace back to glacial interglacial cycles. During Ice Age cold snaps, stronger winds stirred ocean surfaces, boosting plankton growth through upwelling nutrients. When these microscopic organisms died, their carbon-rich bodies sank into deep basins where low oxygen slowed decay. Subsequent warm periods raised sea levels, flooding these basins with sediment that sealed the organic matter away. The North Sea's Brent oil field, a pillar of Europe's energy supply, exists because Ice Age winds supercharged marine productivity there 250 million years ago, while later glacial erosion shaped the rock formations that trapped the resulting hydrocarbons. Natural gas reservoirs often reveal the Ice Age's brute force. In Alaska's North Slope, methane hydrate deposits, frozen mixtures of gas and water, formed when falling sea levels during glacial maxima exposed continental shelves, allowing permafrost to extend offshore and cap migrating gases. Elsewhere, glaciers acted like geological bulldozers, scraping away surface layers and creating fractures that allowed deeper gas to migrate upward into traps. The Marcellus Shale, spanning several U.S. states, owes its economic viability to Ice Age erosion that thinned overlying rock, bringing its gas-rich layers within drilling range. The cruel irony: these ice-forged fuels now drive the climate changes threatening Earth's remaining glaciers. Burning Carboniferous coal releases carbon dioxide, last seen in the atmosphere when palm trees grew in Antarctica. Melting permafrost unleashes methane from Ice Age reservoirs, accelerating warming in a feedback loop our ancestors couldn't have imagined. Yet there's also opportunity in this connection. By studying how Ice Ages concentrated energy resources, geologists are discovering new patterns like how glacial meltwater channels often mark prime locations for uranium deposits, or how certain glacial clays conceal carbon dioxide underground in modern sequestration projects. What emerges is a profound lesson in planetary systems. The same climatic forces that buried ancient swamps under ice are now, through their fossilized energy legacy, dismantling the frozen worlds they helped create. As we tap these reservoirs of prehistoric sunlight, we're not just burning fuel, we're unleashing the climatic ghosts of Ice Ages past and writing a new chapter in Earth's long story of frozen and thawed extremes. The Animal Kingdom's playbook for surviving the Ice Ages reads like a manual of extreme innovation, a catalogue of biological hacks that pushed evolution to its creative limits. Take the woolly mammoth. Its genetic code recently resurrected from permafrost-preserved DNA. Scientists discovered special mutations in its hemoglobin that allowed blood to release oxygen more efficiently in freezing temperatures, essentially turning its circulatory system into an antifreeze network. Reindeer developed another trick. Their nasal passages evolved to warm frigid air before it hit their lungs, while specialized eye structures shifted color vision to detect lichen hidden under snow. Even tiny wood frogs perfected cryopreservation, flooding their bodies with glucose to survive being frozen solid for months, then thawing back to life as if hitting a biological reset button. Human survival during glacial periods hinged less on physical adaptation and more on cognitive revolution, the ability to turn scarcity into strategy. When Neanderthals faced dwindling big game, their response was brute force hunting, pursuing mammoths across treacherous terrain. Homo sapiens took a different approach, crafting lighter projectile weapons like atlatls to hunt from safer distances and setting traps that conserved energy. But the real breakthrough came in social innovation. Ice Age humans didn't just share food, they engineered systems of delayed reciprocity. At sites like Dolní Věstonice in the Czech Republic, archaeological evidence shows communities pooling resources during harsh winters, with toolmakers trading blades for seamstresses' tailored hides. This web of mutual dependence transformed survival from an individual struggle into a collective enterprise. Perhaps the most underappreciated adaptations were psychological. Analysis of cave art from Lascaux to Chauvet reveals a fascinating pattern. During glacial peaks, depictions of prey animals became hyper-detailed, almost obsessive. Some researchers interpret this as a form of cognitive mapping, a way to mentally catalog every advantage when hunting grew desperate. Similarly, the explosion of symbolic artifacts, beads, carvings, ochre pigments suggests symbolic thinking wasn't just cultural expression but a survival mechanism, strengthening group identity when isolation meant extinction. These ancient lessons resonate eerily today as we face climate disruptions. The mammoth's hemoglobin adaptations inspire new techniques for preserving transplant organs. Reindeer physiology informs designs for Arctic-grade respiratory gear, but the most vital insights come from how societies adapted. Just as Ice Age humans diversified food sources, shifting from megafauna to fish, plants, and small game when needed, modern agriculture is rediscovering crop diversity as a hedge against climate volatility. The Inuit practice of silotunic, continuous decision-making based on environmental cues, mirrors contemporary adaptive management strategies for rising seas. The frozen past whispers a paradoxical truth. Extinction isn't just about strength, it's about flexibility. The mastodon's massive size couldn't save it when forests shrank, while the adaptable red fox thrived by switching diets and expanding territories. As glaciers retreat today, we're left with a choice: cling to rigid systems like species destined for the tar pits, or embrace the radical adaptability that kept our ancestors alive when the world froze over. Their legacy isn't just in bones and tools, it's in the enduring principle that survival favors not the strongest, but the most responsive to change. Earth's climate has always danced between extremes, swinging from tropical hothouse to frozen tundra over millennia like a slow-motion pendulum. For the past 12,000 years, we've basked in the warm embrace of an interglacial period, but the rhythm of ice ages suggests this reprieve is temporary. The big question isn't whether glaciers will reclaim the continents, it's when, and whether human fingerprints on the atmosphere have permanently altered nature's clock. Digging into the planet's icy archives reveals a startling pattern. Over the last million years, glacial periods have dominated, each lasting roughly 100,000 years, punctuated by brief interglacials like ours lasting 10 to 15,000 years. Based on orbital cycles alone, those slow wobbles in Earth's tilt and orbit known as Milankovic cycles, we should be nearing the end of our current warm spell, with cooling trends already underway. Ice cores from Antarctica show carbon dioxide levels naturally dropping as interglacials wane, typically signaling the slow march toward the next freeze. But here's the twist: instead of declining, CO2 has skyrocketed to levels unseen in 3 million years, thanks to industrial emissions. This isn't just a deviation, it's a planetary-scale intervention. Climate models paint conflicting pictures of what comes next. Some suggest that even with current warming, orbital forces could eventually override greenhouse gas effects, plunging us into glaciation within 50,000 years, a blink in geological time. Others argue we've likely suppressed the next ice age entirely, having injected so much carbon into the atmosphere that natural cooling mechanisms can't regain traction. The irony is profound. By burning the fossilized remains of ancient forests, many of which grew during past warming periods, we may have severed the link between Earth's orbit and its climate. Yet nature has wild cards up its sleeve. The shutdown of ocean currents like the Atlantic Meridional Overturning Circulation (AMOC), which brings warm water northward, could theoretically trigger regional cooling strong enough to birth new glaciers even on a warmer planet. We've seen previews of this, the Younger Dryas event 12,000 years ago, when melting ice disrupted currents and temporarily reversed warming, shows how quickly local climates can flip. Some scientists speculate that losing Arctic sea ice might ironically increase snowfall at high latitudes, creating the bright, reflective surfaces needed to jumpstart glaciation. The most haunting uncertainty lies in feedback loops. Thawing permafrost releases methane, which accelerates warming, but could also seed cloud formations that reflect sunlight. Wildfires blacken ice sheets, hastening melt yet volcanic eruptions which increase in frequency as glaciers retreat and crust rebounds, can cool the planet with sun-blocking ash. These competing forces make predictions fraught, but one thing is clear: for the first time in Earth's history, a single species holds the thermostat. Whether we're delaying an inevitable ice age or canceling it outright, the frozen chapters of our planet's past remind us that climate has never been a passive backdrop, it's an active force, and we've become its unlikely conductors. The ice ages aren't just relics of a frozen past, they're a blueprint for our planet's future. Every groove carved by glaciers, every layer of ice trapping ancient air, every erratic boulder dropped by melting ice holds clues to how Earth's climate system works. And right now, that knowledge is more critical than ever. As we face rising temperatures, vanishing species, and chaotic weather patterns, the lessons locked in these frozen archives offer something priceless: context. They show us what natural climate change looks like, how fast it can happen, how ecosystems respond, and most importantly, how different today's human-driven crisis truly is. Take glacial retreat as a warning system. By studying how ice sheets collapsed in the past, like the Laurentide ice sheet's breakup 14,000 years ago, scientists can predict how modern glaciers might behave. The parallels are unsettling. Back then, meltwater pulses caused sea levels to rise at rates of over 2 inches per year, drowning coastlines within generations. Today, satellites detect similar acceleration in Greenland and Antarctica, with some glaciers hemorrhaging ice at unprecedented speeds. But here's the key difference: natural ice age transitions unfolded over centuries. Human activity has compressed similar changes into decades. Understanding that discrepancy could mean the difference between adaptation and catastrophe. Beyond climate science, Ice Age relics are biological treasure chests. Permafrost preserves genetic material from extinct species, offering biotech breakthroughs, like the revival of ancient plant genes to engineer crops resistant to drought or cold. In Norway's Svalbard Global Seed Vault, dubbed the Doomsday Vault, scientists store seeds from around the world, mimicking how glaciers once naturally preserved biodiversity. Meanwhile, glacial archaeology programs race to recover artifacts emerging from melting ice, like the 8,000-year-old wooden skis found in Norway or the Incan child mummies revealed by Andean glacier retreat. These finds aren't just curiosities, they're pieces of humanity's survival playbook, showing how cultures thrived in extreme conditions. Protecting these frozen records demands innovative stewardship. In Switzerland, engineers drape glaciers in reflective geotextiles to slow summer melts, buying time for climate policies to take effect. The Ice Memory Project, a global effort led by glaciologists, drills ice cores from endangered glaciers and stores them in Antarctica, creating a backup of Earth's climate data before it's lost forever. Even tourism plays a role. Responsible glacier hikes and educational programs foster public support for conservation, turning awe into action. The responsibility extends beyond scientists. Every ton of carbon we emit steals data from future researchers, melting the very archives we need to navigate an uncertain climate. Indigenous communities like the Sami in Scandinavia or the Inuit in Greenland offer models for sustainable coexistence with icy ecosystems, blending traditional knowledge with modern conservation. Their message is clear: the ice doesn't just belong to us, it's a bridge between generations. What's at stake isn't just the past, but our capacity to learn from it. When we lose a glacier, we're not just losing ice, we're erasing chapters from Earth's survival guide. The irony is profound. The same industrial prowess that unlocked these frozen histories now threatens to destroy them. But there's hope in that duality. If humans can alter the planet enough to melt ice sheets, we can also choose to protect what remains. The Ice Ages teach us that change is inevitable, but the pace and outcome, those are still ours to shape. As we stand at the intersection of deep time and the present moment, the fingerprints of Ice Ages surround us in ways both obvious and astonishingly subtle. That gentle hill in your local park, likely a glacial moraine, the smooth boulder by the roadside, a glacial erratic carried hundreds of miles before being abandoned by melting ice. Even the rich soils that grow our food owe their fertility to wind-blown glacial dust called loess. These frozen chapters of Earth's history aren't just academic curiosities, they're the foundation upon which modern civilization was built. Consider how Ice Age geography dictated human destiny. The very locations of our greatest cities, London, New York, Montreal, were shaped by glacial processes that created natural harbors and fertile plains. The networks of rivers we rely on for transport and agriculture were carved or redirected by ice sheets. Even our mineral wealth, from the gold fields of California to the iron ranges of Minnesota, exists because glaciers concentrated precious metals like nature's own mining engineers. The more we examine our world through this lens, the clearer it becomes. We are all living in an Ice Age's aftermath, beneficiaries of its brutal yet creative forces. What makes this legacy so urgent to understand is how actively it still influences our present. The same groundwater reservoirs that quench modern cities were filled by meltwater thousands of years ago. Coastal communities built on land still rebounding from ancient ice weight face complex challenges as sea levels rise. Even climate change models rely on ice core data to predict future scenarios, proving that the frozen past holds keys to our planetary future. This isn't just history, it's an ongoing conversation between Earth's memory and our unfolding story. the most profound lesson may be one of perspective. Ice ages teach us that change is Earth's only constant, that landscapes we consider permanent are merely snapshots in geological time. Yet they also show nature's remarkable resilience, how life adapts and even thrives in the face of radical transformation. As we navigate our own era of environmental upheaval, these frozen epochs offer both warning and hope, a reminder of how fragile our world can be and evidence of its extraordinary capacity for renewal. So the next time you feel solid ground beneath your feet, remember, you're standing on a palimpsest of ice. Each valley, each lake, each layer of soil tells part of a story that began when woolly mammoths roamed where your home now stands. That story continues today, written in melting glaciers and shifting seasons, inviting us to become not just observers but thoughtful participants in Earth's grand narrative. The ice ages may be behind us, but their legacy is very much alive, and understanding it just might help us shape what comes next. If these frozen mysteries have sparked your curiosity, you're not alone. Share your own Ice Age discoveries in the comments. Have you spotted glacial grooves in local bedrock? Found an erratic boulder in an unexpected place? The conversation doesn't end here. For more journeys into Earth's hidden past, make sure to subscribe and hit that notification bell. Our planet's story is always unfolding, and we've only just begun to read the chapters written